All right, there's my round of applause again. Thank you guys so much. You are the best. Okay, so I'm trying this a little bit differently. I'm trying to do it to see if this video will happen in landscape mode rather than portrait. Oh, well, there's another round of applause. Thank you so much. I guess I didn't pause YouTube when I did that. Okay. Oh, give me a second. All right. So I'm going to try this and see if it works. Just because I know portrait mode is annoying and it like is really small to look at. Again, like this is on, you know, a dictionary, a thesaurus, and the new dictionary of cultural literacy, and the game What Do You Meme? Like those are all stacked up, and my phone is on top of that. Trying to create my own document camera still because my document camera doesn't work. So that is why it just looks a little bit funny. So if you could bear with me. Okay. The last thing that we're talking about this week is transformations of quadratic functions. Now, when we did this in class, we looked at a few different ones in terms of like what happens when you add or subtract a number. But this week, or for this, we're just going to look at what's called a-value transformations. So a-value, remember, if I haven't said it enough this week, y equals ax squared plus bx plus c is our standard form. So really what we're looking at is what happens when we change the value of a. So sometimes we can change it to make it a bigger number than 1 or something less than 1, like a decimal or a fraction, or we can make it negative. So we're going to kind of look at those. And we did these as this was the transformer station, if you remember. So why don't we all get our calculators out here? And I want to take a look at, so we have y equals x squared, 5x squared, and 0.5x squared. So again, there's like, this is in standard form. It would just be that like b is 0 and c is 0, right? So we have like nothing after those. But so just really y equals x squared. And then change the value of a here in x squared, it's 1. And y2 equals 5x squared. Then the a value is 5. So here a is 1. Here a is 5. And here a is 0.5. So this is 1. This is a number bigger than 1. This is a number between 0 and 1. So 0 is less than a is less than 1. Sorry, that's like horrible to read. But I don't want to say less than 1 because then you'll think it's negative, but that's not true. Okay, so let's graph these. So you go to y equals, clear out anything you have in there. And let's see, I'll make this a little bit bigger so you can see. So I have x squared, and then in y2, I'm going to put 5x squared, and in y3, I'm going to put 0.5 x squared. And I'm going to graph all of these at the same time. So remember, y1 is blue, y2 is red, and y3 is black. And it'll graph it in the order that you put it in, right? So y1, y2, y3. Sorry, my calculator has such a lag on it. It's crazy. All right, so blue, remember, was y equals x squared. And then, so that's blue, and then red, and then black. So if we look at blue, and actually, I'm just going to take out the 0.5x squared for a second, just so we can compare two of these at once. Might be a little bit easier. So there's y equals x squared, and there's y equals 5x squared. Well, what happened? So like, what did that multiplying by 5 make it do? Well, you have a graph, you know, that was kind of out like this and was sort of like pushed in, right? So this is called a compression. When it gets like skinnier, like that. Skinnier is not the math term, compression is, but you can say skinnier if it helps. Just know that that means compression. All right, so this is x squared, this is 5x squared. So if you're multiplying it by 5, you compress in. And then let's go back to this, and I will add in my 0.5x squared again. And remember, blue is still x squared, okay? So now you're looking at from blue to black, what happens? Well, it got wider, right? So it like stretched out. So 5x or 0.5x squared went out. So it went out from x squared rather than in. And so if you look at that, that's called a stretch. So it got wider. You're like, well, that's weird because like, why would a big number make it get skinnier or compress it and a small number make it stretch? Well, for that, let's look at the table. So your x is all over here. Your y1, remember, is x squared. Your y2 is 5x squared. Your y3 is 0.5x squared. And if you look at this, so for x squared, you have 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. So all the perfect squares, right? 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Now, with y2, you're taking that squared value and you're multiplying it by 5, right? Because you have 5x squared. So 5 times 0 squared is still going to be 0. 5 times 1 squared is 1, times 5 is 5. 5 times 2 squared is 4, times 5 is 20. 5 times 3 squared is 9, times 5 is 45. Okay, and you're like, yeah, okay, I get it, I see that. So why does the graph change? Well, because if you're looking at this, so like, and I did not actually graph this, didn't graph it accurately. I sketched it, but if you were looking at this on another graph, so you have 0, 0, 2, 3. Oh, I guess we don't need those. Okay, so they all hit 0, 0, right? X squared, just regular x squared. If I have 1 squared, it's 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is also 4. Okay, so that's my graph of x squared. 5x squared. Like, why does it get skinnier? 0 squared times 5 is still 0. 1 squared is 1 times 5 is 5. 1, 2, 3, 4, 5. So at 1, x equals 1, instead of my value being 1, like it is at x squared, it's 5 at 5x squared. And negative 1 squared is also 5. So that's why that gets skinnier, right? And then the same thing is true, opposite thing is true for 0.5. So if I look at like 1 squared is still 1. Times 0.5 is 0.5. And same over here. It's easier if we look at another point on this one too. So 2 squared is 4. But if you do 2 squared, which is 4, times 0.5, it's down to 2. And then 2 will also be 2. So now this goes way out like that. So that's why you see that skinny, that compression for numbers that have a coefficient that's larger than 1, because you're multiplying that by a number greater than 1, so it's going to make it grow faster. And when things grow faster, they look steeper, right? We know that from our study of linear functions. And the same works for quadratic functions. And then on the opposite side of that, when you multiply by a fraction, you're multiplying by something less than 1. So that's going to take the y value down, okay? So y equals x squared, if you look at number 3, because it went 1, 2, I got it. So you still have y equals x squared, so we're good there. Y equals 2x squared, that's a number that's a is bigger than 1. that means it's going to compress. So it's going to be skinnier because we're going to take x squared and we're going to multiply it by 2. So it's going to grow faster. And then you look at the opposite. So you have 1/4 times x squared. So a is less than 1. So that's going to stretch because you're taking whatever your value is of x squared and multiplying it by 1/4 or dividing it by 4. So it's going to grow slower. So let's use actual points for this one. So I have, just for y equals x squared, so I have 0, 0, 1, 1, negative 1, 1, 2, 4, 2, 4. 3 would be up at 9, and 3 here would be up at 9. All right, so I'm going to try the best I can to make that. All right, and as you can see, it's a lot easier to do on paper than it ever was on my smartboard. Okay, so now x squared times 2. So 0 squared is 0 times 2 is still 0. 1 squared is 1 times 2 is 2. And the same thing on the opposite side at negative 1. 2 squared is 4 times 2 is 8. And then negative 2 would also hit at 8. Sorry, that was supposed to go over there. So if you draw that again, it's skinnier. It's not as much skinnier as it was when we did like the 5s, but you can see that it still compresses that again because you're taking every y value that you would get when you plug in x squared and you're multiplying it by 2. Okay, now I have 1/4 x squared. So 0 squared is still 0 times 1/4 is still 0. 1 squared is 1 times 1/4 is 1/4, which is going to be impossible to graph, so I'm just going to try to move on to 2. 2 squared is 4 times 1/4 or divided by 4 is 1. And it would be on that negative 2 as well. 4 squared is 16, which is way off of this graph, but if I divide it by 4, it's not. So I can go right there. I skipped 3, sorry. I don't really know why. So again, you can tell that this is going way wider. So that's y equals 1/4 x squared. So what you need to know from this, if you need to be able to look at that and say, okay, well, what's it going to do? Is it going to be skinnier? Is it going to be wider? So is it going to compress or is it going to stretch? And again, the rule is if a is greater than 1, it's a compression. And if a is less than 1, it's a stretch. So a skinnier parabola, a wider parabola. Okay. So we don't have to, we kind of did the bottom of this. We worked through it together, so we're not going to do that. We're just going to move on. We're actually skipping transformation 2 because we're not really concerned about the pluses at this point. So you're going to go to transformation 3. Now, we have y equals x squared, y equals negative x squared. So here's the deal. A is 1 here, a is negative 1 here, but really the only thing that makes it go skinnier or wider or compress or stretch is if it's either greater than 1 or between 0 and 1. So negative 1 is not between 0 and 1. Negative 1 is its own little animal here. So we have to kind of see what's going to happen there. And I think probably you already know, but we're going to do it anyway. So if I take a look at my calculator again, and just clear out what I already did. So y equals x squared and y equals negative x squared. If I hit graph, there's y equals x squared. There's y equals almost, there we go, negative x squared. And you're like, ooh, it's a reflection. How exciting is that? Well, why? Okay, well, here we go. 0 squared is 0. 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is also 4. So here is our traditional y equals x squared. Well, now you're going to take y equals x squared and you're going to multiply it by negative. Because remember, that negative is not in with x squared. Like, it's not negative x squared. It's negative x squared. And I hope you're looking at that while I said that, because I said the exact same things. You had to understand, like, you know, what the difference is, right? So there is, the negative is not inside the parentheses. So you're not squaring a negative x. You're squaring x and then multiply it by negative 1. Okay. So 0 squared, still 0, times negative 1, still 0. 1 squared is 1 times negative 1 is negative 1. 2 squared is 4 times negative 1 is negative 4. Right? So now I just have the reflection of that. And it looks skinnier, but it's not. It's only my graphing issues. So over here, I have y equals 2x squared and then negative 2x squared. And actually, let's just say x squared for a second. Okay, let's just take that 2x squared out. So here what's going to happen, so I'm still going to have my regular graph. 0 is 0, 1, 1, 2, 4, and negative 2, 4. I'm singing along with my little drawing here. Okay, so that's y equals x squared. Now, y equals negative 2x squared. 0 squared, 0 times negative 2 is still 0. 1 squared is 1 times negative 2 is negative 2. And then same thing for x equals negative 1. 2 squared is 4 times negative 2 is negative 8. And then negative 2 is the same thing. So if I graph, this not only looks like it flipped over, reflected, that's what that's called. It's a reflection when it does that. But it also compressed. And so on some of these, you're going to have to look and see, okay, well, there's like multiple things happening in the same A value. So not only is A technically, well, the absolute value of A is greater than 1, right? Because it's negative 2, but 2 is greater than 1, certainly. But it's also a negative A, so that's going to make it a downward facing parabola. So you have two different transformations going on there. All right, so here's like your takeaway from the day. And that is, again, if A is greater than 1, your graph is compressed. And again, if you need to think of that as skinnier, you can. If A is less than 1, that's a stretch, and that's a wider graph. If A is negative, it's a reflection over the x-axis. Okay, so those are the three things that you have to know. 1, 2, 3 for what we call A, you can't see that, A value transformations. Cool? All right, well, that is your last lesson for the week. Yay, yay, woohoo, yay. So I hope that you enjoyed your first week of online learning. Do not forget to go to Delta Math and get your assignment done. That has to be submitted by 3 o'clock on Friday, April 24th. So, of course, I will say again, if you have questions as you go through any of this, please feel free, email me, shoot me a message on Remind, or hit my office hours, which are Zoom meetings on Mondays from 10 to 11, Tuesdays and Thursdays 10 to noon. And you can just pop into that meeting with a question and pop back out. I'll send, like I said before, I'll send the Remind out that morning. That'll give you the ID and password. I honestly believe it's the same thing every time. So if you write it down once, you should be able to get in to any of those meetings anytime. Other than that, just remember that if you do have a Delta Math question, to screenshot it so that I can see what exactly you're looking at. and I can kind of walk you through it. Oftentimes on delta math, it's not that you're wrong, it's just that you're like inputting it wrong. And so it can get a little bit shaky in terms of, you know, exactly, excuse me, exactly what they're looking for. All right, but other than that, that's it. I will talk to you guys later. Have a good one.